Good day, and welcome to another session of Larteen Math Tribe tutorials. In these tutorials, we will learn how to use the scientific calculator to perform calculations involving rational and irrational numbers. We will learn how to distinguish rational and irrational numbers using our scientific calculator. So, if a particular number is given to you, how do you determine whether that number is a rational or an irrational number? So that is what we are going to discuss about in this tutorial. Now, before we move on to use the scientific calculator, let us first discuss about rational and irrational numbers. In simple terms, rational numbers are numbers which can be expressed as a fraction. So if you have any number that can be converted or written in the form of a fraction, then that particular number is a rational number. Rational numbers include proper fractions, improper fractions, mixed fractions. So these are all types of fractions. And since they are fractions, then we can also say that they are rational numbers. Integers are also rational numbers. So integers are positive and negative whole numbers. So why are we saying that integers are rational numbers? Example, if you have the integer 2, 2 can be expressed as a fraction, which is 2 out of 1. And since 2 out of 1 is a fraction, then we can conclude that it is also a rational number. We also have terminating decimals. So terminating decimals are also rational numbers. And what are terminating decimals? So terminating comes from the English word, which means to put an end to something. So terminating decimals are decimals that have an end. For example, if you have the decimal 0.33, we know that the end of this particular decimal is 3. So 0.33 is the same as 33 out of 100. And since 33 out of 100 is a fraction, then we can conclude that it is a rational number. We also have recurring decimals. So recurring decimals are decimals that do not have an end after the decimal point. For example, if you have 0.33333333 up to infinity, then we can say that this particular decimal is a recurring decimal. Recurring decimals are non-terminating and repeating. Initially, we stated that terminating means the number comes to an end. So this implies that non-terminating means it continues up to infinity. So if you have 0.333 up to infinity, it is the same as 1 out of 3. Now, let us move on to talk about irrational numbers. So irrational numbers is the direct opposite of rational numbers, and these numbers cannot be expressed as a common fraction. And when these numbers are converted into decimals, they are non-terminating and non-repeating. So non-terminating simply means they do not end, and non-repeating means they do not repeat after the decimal point. For example, if you have the number pi is the same as 3.141592653. It continues up to infinity. So we can see that after the decimal point, the number continues up to infinity, so it is non-terminating. And also, the numbers after the decimal point do not repeat. They are just random numbers. So that is the reason why we say they are non-terminating and non-repeating. So this applies to all irrational numbers. And there is no way these numbers can be converted into a fraction. I hope you have gotten a fair idea on how rational and irrational numbers are. So let us move on to how to use the scientific calculator. We know that rational numbers are numbers that can be expressed as a fraction. So the idea here is that if the calculator is able to convert a particular number into a fraction, then that number is a rational number. We also know that irrational numbers cannot be expressed in the form of a fraction. So if the calculator is unable to convert a particular number into a fraction, then we can conclude that that particular number is an irrational number. So that is basically the idea that we are going to use in this particular tutorials. So we are going to use some sample questions which have been designed to help us familiarize ourselves with how to distinguish rational and irrational numbers using our scientific calculator. So without wasting much time, let us move on to the questions. So these are the questions. And for our first question, we have to sort the following into rational and irrational numbers. A, we have 0.314. So what we have to do is to first input the number into the calculator, and afterwards we tap on equal to. And as I earlier stated, if the calculator shows the result as a fraction, then we conclude that that number is a rational number. But if the calculator is unable to show the result as a fraction, then we conclude that it is an irrational number. So A, we have 0.314. which is a terminating decimal. So I input that into the calculator, 0.314. And afterwards, I tap on equal to. So 0.314 is the same as 157 out of 500. And because the result appeared on the calculator as a fraction, then we conclude that 0.314 is a rational number. Now, let's move on to B. For B, we have 0.6666, and there's a 3 dots attached to it, which is telling us that this particular number is a recurring decimal. It moves up to infinity. So I input exactly that into the calculator. So we have 0.666666. So I input as many numbers as I can. But what you have to make sure is that the numbers that you are inputting into the calculator should be at least 14 in order for this to work. So I have successfully inputted the number into the calculator. So I simply tap on equal to. So 0.6666 up to infinity is the same as 2 out of 3. And because 2 out of 3 is a fraction, then I conclude that this particular recurring decimal, which is 0.6666 up to infinity, is a rational number. Now, let's move on to C. For C, we have square root of 45. So I input square root of 45 into the calculator. Square root of 45. And afterwards, I tap on equal to. So the calculator gives the result as 3 root 5. And because the result did not appear on the calculator as a fraction, then we conclude that square root of 45 is an irrational number. So let's move on to D. For D, we have the square root of 7,396. So I input that into the calculator. 7,396. And afterwards, I tap on equal to. So the calculator gives the result as 86, which is an integer. And we know that all integers are rational numbers. Because if you have 86, 86 can be expressed as 86 out of 1, which is also a fraction. So I can conclude that the square root of 7,396 is also a rational number. Let's move on to E. E, we have 0.732346892148, and there's a 3 dots attached to it, which is telling us that this particular number moves up to infinity. So I input exactly that into the calculator. So we have 0.732346892148. And there's a 3 dots attached to it, which means it moves up to infinity. But there is no way we can predict the next numbers because these are just random numbers. So I have successfully inputted it into the calculator. So I simply tap on equal to. So this is the result, and the calculator couldn't display it as a fraction. And because this is not a fraction, we conclude that it is an irrational number. Now, let us move on to F. F, we have 1.415415, and there is also a 3 dots attached to it, which is telling us that this particular number moves up to infinity. But for this particular number, we will be able to predict the next numbers because it follows a specific pattern, which is 415, 415, 415, 415 up to infinity, which is different from the previous one we just did. So I input exactly that into the calculator. So we have 1.415415. So I input as many numbers as I can. But the numbers should be at least 14 as I indicated earlier. So I think it is okay. Afterwards, I tap on equal to. So this is the same as 1,414 out of 99, which is a fraction. And because the calculator displayed the result as a fraction, we conclude that this particular number is also a rational number. Now, let's move on to the second question. Which of the following sets is rational? So we've been given two sets, set A and set B, and we have to determine which one of them is rational. So what we have to do is to test for the elements of each of the sets, one after the other, in order to determine which one of them is rational. So when we pick set A, we test for all its elements, and afterwards we pick set B and also test for all its elements, in order for us to be able to determine which one of them is rational. So let's start from set A. So for set A, we have square root of 4, 0.3636, and we also have square root of 8. So we test for the elements one after the other. So let's start from the first element, which is square root of 4. So I input square root of 4 into the calculator, and afterwards I tap on equal to. So square root of 4 is the same as 2. And we know that 2 is an integer, and all integers are rational numbers. So I can conclude that square root of 4 is a rational number. Now, let us move on to the second element. For the second element, we have 0.3636, and there is a 3 dots attached to it, which is telling us that this particular decimal is a recurring decimal. It moves up to infinity. So I input exactly that into the calculator. 0.3636. So I input as many numbers as I can. And the numbers should be at least 14 as I indicated earlier. So I have successfully inputted the number into the calculator. So I simply tap on equal to. So 0.3636 up to infinity is the same as 4 out of 11. And 4 out of 11 is a fraction. So we can conclude that this particular recurring decimal is also a rational number. Now, let us move on to the third element. For the third element, we have square root of 8. So I input square root of 8 into the calculator. And afterwards, I tap on equal to. So square root of 8 is the same as 2 square root of 2. And because the calculator did not display the result as a fraction, we conclude that square root of 8 is an irrational number. So we have tested for all the elements of set A. And now, what will be our conclusion? For set A, there is a particular element, square root of 8, which is an irrational number. And because that particular element is an irrational number, then we conclude that the set A is not rational. Now, let us move on to test for the element of set B. So for set B, we have square root of 16, 5 square root of 9, and 0.25. So we test for the element one after the other. So for the first element, we have square root of 16. So I input square root of 16 into the calculator. Square root of 16. And afterwards, I tap on equal to. So square root of 16 is the same as 4. And 4 is an integer. And we know that all integers are rational numbers. So I conclude that square root of 16 is a rational number. Now, let us move on to the second element. For the second element, we have 5 square root of 9. So I input that into the calculator. 5 square root of 9. And afterwards, I tap on equal to. So 5 square root of 9 is the same as 15. And 15 is also an integer. And we know that all integers are rational numbers. So we can conclude that 5 square root of 9 is also a rational number. Now, let us move on to the last element. For the last element of B, we have 0.25. So I input 0.25 into the calculator. And afterwards, I tap on equal to. So 0.25 is the same as 1 out of 4. And because the calculator displayed the result as a fraction, we conclude that 0.25 is also a rational number. So what can we say about set B? Because all the elements of set B are rational numbers, then we can conclude that the set B is rational. I hope you have gotten a fair understanding on how to use the scientific calculator to distinguish rational and irrational numbers. The third example is a try work. Solve it and put your answer in the comment section. I will review it at the appropriate time. We have come to the end of these tutorials, and we learned about how to use the scientific calculator to distinguish rational and irrational numbers. Please, this is a new channel and I really need your subscription. So please subscribe to the channel before exiting this video. My name is Larteen and I hope we had an amazing time together. Thank you and have a nice day.